So many papers, so little time. If you're in science, you probably thought about this a million times. You've got a bunch of lab work to do, but there's this whole backlog of papers, and you need to stay up to date in your field. So what do? Hi, I'm Angela, and we're here to apply AI to biology. So today, we're going to build a Python application that will take in some paper PDFs and make an audio summary that is interesting and engaging and tailored just for you. And we're going to do this in a way that is easily iteratable, and you can use it on unpublished work. So let's dive in. Okay, so we are going to start at the GitHub repo, YT paper to audio. I'll have a link in the description. And the first thing we want to do is clone that. So we go here, copy, pull up the terminal, move to the desktop. So CD has just changed directory, so now we can see we're in the desktop. And then we're going to clone it. So that's just copying all the files that are in the repo to my desktop. With a git clone and pasting that URL. Now if we go to the desktop, we can see that it has cloned itself right here. So now we're going to go to VS Code. Once we're in VS Code, we go to Open, Desktop, YT Paper to Audio. Okay, now we have some papers in there to work with. So we're going to go to the README, and this is the markdown version of it, but if you go here, you can see it a little bit more nicely. If you go to the requirements section, we see that we need Python 3.13. That's a specific version of Python. We also need UV, which is a package manager. And then we need an Anthropic or an OpenAI API key because we're going to be using an LLM to do part of this workflow. So we've already cloned it. I guess we can CD into it. So if you go to terminal, new terminal, this is where we are. You can always type pwd just to check. So we're at users and desktop YT paper to audio. So this is where we're sitting. If you don't have UV, you'll have to do another step to install UV. I'm going to do a UV sync command. And it is going to create this .venv, which is going to contain all the things that we need to run these notebooks. So all of the libraries which are specified in this PyProject TOML file. So all these dependencies here, it has gone around and installed these. Then we need to create a new .env file. We have copied this example env, and then the real one is right here. I'm going to use an Anthropic API key, so I don't need that one. And I am gonna go here. So I'm gonna go here and I am going to create a key just temporarily for the purposes of this video, and I'll delete it afterwards. Gonna add that. And then we get this API key that we're just going to copy right into here. We'll save that. We could run it on the command line. That's command line interface, CLI, with this command. But let's run it in the notebook just so that we can see what's going on. So we want to make an audio summary of a scientific article. The first thing we do is we specify where our PDF is stored and which one we're going to be using. This is the skill file that we are going to create. This is the output directory that we want all our output files saved to. So how do we make this skill file? I already do have a default one stored here. And this is accessible not only to this script, but also if we wanted to invoke this skill in Claude, we could do so. And this skill.md file has this interesting content at the top, the name, the description, so that the LLM can read this and know how to orient itself. Like, what is this skill used for? When do I use this skill? If we kind of take a look at it in the VS Code's format, then it's a little bit easier to read. So it gives it a title, basic information, what are the core constraints, audience profile, and all of this was generated by Claude. Claude Code, as of a couple of days ago, had a skill creator option. I don't know where it's gone now, but we do know that Claude Desktop most certainly has it. And we want to create a skill. So we're going to invoke the skill creator right there. And then we're going to describe what skill we want it to create. So I already wrote a prompt, so I'm just gonna paste that in. Convert a scientific paper into a 15-minute entertaining and informative summary optimized for audio. I've specified the input, which is gonna be text extracted from a scientific paper. The output, which is gonna be a script that includes only the words a narrator will speak in the audio. It should begin with today's paper is called, say the paper's full title, introduce the main authors, and then who is the audience? So who should they be optimizing this for? The audience is a person with a strong background in histopathology, machine learning, who wants to learn more about cancer immunobiology. If immune cell types are discussed in the paper, make sure to put some emphasis on the roles those cells play. So you can see, you can really streamline format. If the paper talks about ML models used, break those down into simple terms, but feel free to get technical since this audience has a good ability to understand the content. So that looks good. I'm going to submit this and it is going to create a really good skill. So while you can create your LLM prompt from scratch, I have found that this has not yielded as good of results as I have been able to achieve with the skill creator skill in Claude. Here is what it came up with. That is an example audio script. Here is the actual skill. Okay, so this is what we need, is the actual skill.md. So if we go to save skill right here, it's going to save it to Claude Desktop, but we want to use this as part of a script so we can maybe do batch processing or things like that. So we're just going to go ahead and copy this and we are going to update this skill.md file. We want to select the right kernel here, so we do kernel, Python environments, and YT paper to audio. That is going to be the one in this .venv. So let's go ahead and run. You can see we're going to be using pypdf to read the PDF and convert it to text. We're going to use the Kokoro model to convert text to audio. And we're also using python.env to load the .env file here. Let's go ahead and just check to see if we have one of these API keys in our environment loaded. And we do, because it hasn't raised an environment error. Our first step is going to be converting our PDF to text. So again, that's going to be the PDF that we put here. This is the function that performs it. And when we run it, we can see that it has saved to this path. So if we go to output, we can see it right here. So this is just the text that was extracted from the paper PDF. Then we need to prepare the prompt for our LLM to create the audio script. So make user input, and all we're doing here is we're just combining the skill instructions with the paper text to create one input that we are going to put into the LLM so that we can get this script back out. And that's going to be stored in user input. Next step, we're going to generate the paper summary. So the model, the LLM we're going to be using is going to be Claude Sonnet 4.6. And this is how you get the LLM to respond to the prompt that we gave it. So the prompt is going to be the user prompt input. The model we have selected as being Claude Sonnet. temperature is going to indicate how much creativity the LLM can have with this. It's good to set it at 0 if you don't want it to fabricate content, because the more creative it gets, the more liberties it can take with the accuracy of what it's saying. And then max tokens is going to be a cutoff for how many tokens it can consume during this process, which is good if you don't want, you know, $100 bill for running something. So then it's just going to return its response, which we're storing in response text. And then we're going to end up saving that to this response file, which we will see. So it is running now. It's using the model. Okay, it's done. It took about 1.5 minutes, and it has saved the summary to summary.txt, which is right here. Oh gosh, it's decided that it was going to do markdown. Well, you can always update the prompt to make it not do that, but it will often do this sort of thing. So we don't want our model to say markdown, so we're going to delete that. And yeah, it's got some backslashes over there. Okay, now we're going to convert that to audio. So TQDM is just giving us a status bar. RE is regular expressions, and we're just going to convert this to speech using K-pipeline, which again is the Kokoro model. So that is just defining the function, and here we're going to be testing it out because some things can go wrong. So we're going to test it on a very small piece of speech. So now let's go ahead and convert the full paper. Okay, so it is done, and we have saved a .wave version, but .wave is rather large, and while it is supposedly better in quality, I don't notice a big difference between that and MP3, and MP3s are smaller and more portable. So let's go ahead and convert that to an MP3 file. We just run that, and it has saved it. So now we've got the MP3 version. What I like to do is actually just upload that to my Google Drive, and then I can access it on my phone and listen to it on my way to work.
Today's paper is called Uniform, Towards Universal Immunofluorescence Normalization for Multiplex Tissue Imaging. The first author is Kunlun Wang, from the Cancer Early Detection Advanced Research Center, known as CEDAR, at the Knight Cancer Institute, Oregon Health and Science University.
The next thing that we can do is actually convert this to a full Python script. So I have that in paper.audio.py, where the input is a PDF, and then ultimately it produces the outputs here, except for the .wave file. So then, if you want to run a batch, which is probably the strength of this sort of approach over things like Notebook LM, you can use this here, change this to your PDF directory path, and then it will just go ahead and batch these. Activate UV. Now we can see that our environment is activated. Actually, probably not have my Conda environment activated. Okay, so this was the Conda base environment. Let's clear this again. Let us run the batch. Sometimes you might have to do this command in order to safely execute this file. So now we know that a plus x, it is executable now. So we can just do run batch.sh, and it is going to go through and it creates subdirectories for each paper and will contain all of the components. So it has already extracted the text for the Canvas paper, and it is going on to use Claude Sonnet to create the audio summary. So it's just going to go ahead and run through every paper in the paper's PDF directory. So I've got 3 here, So it'll just go ahead and do all of those, and then you can have papers to listen to all week. So that's the full pipeline. We use pypdf to extract the text from the PDF. Then we go on to use Claude in order to design a really good prompt for summarizing that text. Then an LLM API call from either OpenAI or Anthropic in order to make the summary. And finally, the Kokoro text-to-language model to generate the audio. Everything runs locally, there are no subscriptions to pay for, just API tokens, and those are pretty much just cents. So very cheap. I've also got a Hugging Face space for trying the Kokoro model out without having to set up an environment. So you can check that out. I've got a link in the description. Later on, I'm planning to do a Hugging Face Spaces setup video, which will help you set up an ML model on Hugging Face Spaces and make it more accessible for people to use. That's all I've got today. Thanks for watching.